Get this on record. So welcome everybody to our Introduction to Networks meeting. Glad you're here. First off, I'm gonna start with a little joke here, just so everybody's we can all see here. I'm a pretty big hockey fan, or become a pretty big hockey fan. So I love this Canadian proper social distancing. So 2 meters apart, or about the length of a hockey stick. So that's how the Canadians do it for their social distancing, which I think is hilarious. I've also seen one about the length for Florida, about the length of an alligator. So that'll give you an idea of how far apart we need to be. So hope everyone's doing well during this craziness that we have here. I'm going to pull the chat up. If you have anything to say, you can definitely pop it in chat, and then I'll be able to look at it and see. I do want to talk about a couple things. First off, this class you will see officially ends April 24th, but I don't want any freaking out. I don't want anybody going nuts. I understand that probably everyone will not finish by the 24th. What's going to happen is you're going to lose access to your to moodle.stanley.edu. You remember, that's just where you did your first assignment and you went in and proved your attendance for me. I'm going to ask that you go to Moodle. God, what in the world? Where did I get that? Talking about old Canvas, not Moodle. Good gosh. But Canvas, and log in for me sometime in the next week, so that just quote, for attendance purposes. I will tell you one of the beautiful things, I believe it was a year ago or so, we actually suggested that our campus go to Canvas. And in light of the COVID-19 outbreak, it has been an absolute great thing. Yes. Who's somebody saying something? Okay, but it's been a great thing because it actually has a phone app, which students have been able to go in and look and do their assignments and get their assignments to a phone app, which is kind of crazy. But if you will go to Canvas, don't go to Moodle, go to canvas.stanley.edu. Again, remember I've been hit by a truck. But go to Canvas for me in the next couple of weeks and log in just to quote, do attendance, which I know you've been inside of NetAcad. But so you are not going to lose access to NetAcad on the 24th of April, and you're not going to lose access to NetLabs. Neither one of those are going to be turned off for you. If obviously you're in this class, so you probably will be taking the next class, which is Routing and Switching Essentials. Well, there I go again. God, I'm getting old. It's Switching, Routing, and Wireless Essentials is what it's called now, but CCNA 2. You're going to be taking the next class, in which case I will give you to the 20th of May to get this class finished. So you need to have it finished up, though, before you start the next class. Expect, by the way, I will give you real quickly just so everybody can see it and know. No, that ain't it. www.stanley.edu. If you ever need to see our current class schedule, you can always go to future or current students, either one, but future students, ASC ITC, Instructor Training Center, and our schedule. And you will see that we have all 4 classes coming up this summer. And we are going to be doing all 4 again in the fall. So if you get the second class, Switching, Routing, Wireless Essentials this summer, you can take Enterprise Network Security and Automation in the fall. If some of you are, let's say you've suddenly found that you don't have a whole lot of classes to teach in the summer, and you're going to have more time than you would otherwise, I will actually allow you to take both CCNA 2 and 3 if this is going to be the primary thing you do this summer. I just don't want you to try to take 2 classes if you're also going to be teaching a full load. You know how much work there is to do in this Introduction to Networks, so you understand how much work it would be to do in the next 2 classes combined. The other thing I'm going to ask is, by the way, if you need to register, just contact Jana or Lydia. Jana can get you registered. Unfortunately, there are no grants this summer. I don't have any grant money. But I am going to ask once again, all of you that are watching this and all of you in this class and in any of my classes this semester, if it was paid for by a Cisco grant, and I need you to complete these classes. I need to have completions so that when Cisco comes to me and asks about grant completions and ask about giving me more grants in the future so that I can take care of you, I'll be able to do that. Which, by the way, I had $15,000 come in, and every bit of it went out to you, the instructors. In fact, I went over And so I spent money directly out of my instructor training center to pay for some instructors to be able to take the classes for free because I had said that that they would be in the grant. And then again, I went over and more people got registered than I planned. And I tried to fix my problem. So we did actually pay for them. So please be aware of that. I need you to finish up. So a couple things. We look at Notepad here. I'm going to hit Notepad. I need you to log in to canvas.stanley.edu sometime in the next 2 weeks. Okay. On April 24th, you will lose, actually be 25th, but still, access to Canvas, but not to Netacad or NetLabs for this class. You have until May 20th if you need it. Now that's one thing. If you don't need it, you don't have to take to the 20th. You can finish up. Just let me know when you want the final turned on. I'll turn the final on for you. The final can only be turned on for a week. And so that's something that we can look at, and I'll turn the final on for you. Last thing, I will tell you this. I'm going to do a session not next week, but the next week, pretty much last week of class, where I'm going to show you how to create classes. I'm going to show you how to do things as an instructor and allow you to get a little bit more information on how to do that. However, I will tell you, because of the fact that you're in an Introduction to Networks course, you should already be enrolled automatically into a orientation course, Academy Orientation. Is that true? Can somebody verify that for me, that you're actually seeing that you're in an Academy Orientation course? As soon as you're actually placed into a Introduction to Networks course, you're supposed to be automatically enrolled in the Academy Orientation course. If that's not true, let me know and I will figure out a way to get you enrolled. But this Academy Orientation course actually shows you everything you need to know about creating classes, creating student accounts, what your role is as an instructor, how to end a course. All of those things are actually inside of this orientation. So if somebody will verify for me or let me know that they do have that or they don't have access to it, so just let me know. And it should be on your I'm Learning page. Okay, anybody? I got a chat here. Chat to chat. Yep, okay, Peter's got it, good. So y'all should have this. So I strongly recommend going through this. And this is what I will be using and talking about 2 weeks from now as we go over creating classes, creating student accounts, and those types of things for you. All right. So any questions before we get into talking about IPv6? I do want to show you one last thing, and you may not have gotten this because it depends on, since you're in the intro class. I do have under my Academy Support Center, and I sent this out, probably your superiors got it, but under my, actually take it back, it's under my in IT Academy. Under the IT Academy, I have a thing called free classes, and I'm 100% trying to rip off the Open University. They're great. They're out of England, and the guys are great. I know them well. I've met them at World Skills. They do an excellent job and give all kind of really good free classes. But on my free classes page, I have here Packet Tracer. I have Introduction to Cybersecurity, Cybersecurity Essentials, Linux Unhatched, Linux Essentials, Introduction to IoT, and Entrepreneurship. All of these are self-enroll, self-paced courses that you can spread to your students and let them use it as much as they want. You can give it to any teacher you know anywhere. I would love for you to do that. The Cisco Academy, I sent something out this week. Actually, it was last week. They've actually created a landing page with the same type of thing for them. This is through my Cisco Academy, and please share it to everybody you know so that that they can use this during this time of COVID-19. It may just be somebody sitting at home wants to learn a little bit about cybersecurity. They could go through these 2 courses here, and it would give them a 45 hours worth of cybersecurity. It gives them access to Packet Tracer. It gives them access to all those things. So, okay, Corey, you don't have it. Okay, if you don't have it, let me know, and I will. I'll try to figure out a way to. I'll get the link for you to be able to and do a video on showing you how to get into the orientation, because you do need that. But share this far and wide. This URL right here. and anybody that wants it is welcome to use it. So, yeah, all right. Any other questions before we go into the module? None? All right. Let's talk about IPv6. IPv6 is obviously the successor to IPv4. I'm not going to spend a long time discussing why we need it, other than the fact that we're out of IPv4 addresses. It's not a matter of we're running out. It is we are out, pretty much. So we're exhausted. So basically, out of our 5 different internet numbers authorities, 4 of them have run out of IP addresses. And Afrinic is going to run out in 2020. So I would figure they're probably already run out at this point. So the address space for IPv4 only had 4.3 billion addresses in it, which sounds like a huge amount, but it's nothing when you start looking at all these IoT devices and everything that's going on now. So IPv6 has been around a long time. It is not something new. It has been, it's been evolving as from its original design, and it's still evolving. I'll tell you that right now. There's still RFCs being worked on or RFCs being looked at, but it's important to know that it has been around a long time. It's also important to know that you probably have it turned on already on your machine if you didn't already know that. If you go to, I'm going to go to Control Panel here, you go to Network Sharing Center, go to your adapter settings, and by default, you will probably see under Properties that IPv6 is turned on already. So by default, it's turned on. Now, obviously, if you're not using it, you could turn that off, and that actually makes it a little more secure. But on most of the machines out there today, IPv6 is already running, and it is available. So if I do a CMD and do an IP config, you'll see that I have a linked local address. I have an IPv6 address. So it is up and running on my machine. Now, because of that, you would say that my system right now is what is called dual stack. So I'm running both IPv4 and v6 at the same time. And that's probably the best way to do things because it allows you to run the protocol natively. You also can tunnel it. So let's imagine you had an IPv6 only network in Chicago, an IPv6 only network in New York, which you're not going to because there's almost no IPv6 only networks. But if it was, and you needed to go across the internet really right now, it actually does support IPv6 in certain portions in certain places. But if you did not support it, you could just put it through an IPv4 tunnel. So you could tunnel IPv6 inside of IPv4. Let me turn my phone off, y'all. I don't know why I'm getting 5B and pings right now. All right. The last way they can coexist is translation. So you can do a NAT 6-to-4 router. So we can convert between IPv6 and IPv4. However, I will tell you this NAT 6-to-4, 4-to-6 is kind of being frowned upon. Well, not just kind of, is being frowned upon. It's something that they're not really suggesting people do. They're suggesting you do more dual stack if possible. Okay. So here's where things get very interesting. So IPv6 is a 128-bit addressing scheme, which is like 300 and something undecaying. It's crazy. It's enough IP addresses, they claim, to put an IP address on every grain of sand on the planet Earth, which sounds nuts, and that we will never use it, but we used to say the same thing about IPv4, that we would never use all those. When we have nanobots and every one of them have an IPv6 address, we'll run out of IPv6 addresses sometime. But these are 128-bit addresses. They're represented as hextets. So there are 16-bit segments or hextets. Originally, we used to call them hextets, and everybody said, well, that's an unofficial term, and then it became an official term. But it's a hextet. And so it is written in hexadecimal. My internet connection is unstable, so I'm gonna wait and let it. My internet connection, if I broke up right there, I apologize. My internet connection was unstable, so hopefully it has cleared up. When you look at IPv6, one of the big things you're going to get is you're going to get questions on how to do the preferred format and how to do the reduction size of an IPv6 address, because they are huge. I'll tell you too, I think as we move along, we'll see more people getting hexadecimal keypads on their keyboards. Those actually exist, by the way. You can actually buy a little USB hexadecimal keypad. But I think you'll see that more and more as we go forward. But here's some different examples of IPv6 addresses. Now, obviously, these are very long. They're unwieldy, and I'll be quite honest with you, they are hard to type in because they're easy to fat finger. When you have this many digits and numbers, well, digits and letters to put in. So they came up with some rules. They said, first thing you can do in any hexdet, if there's a leading 0, you can omit it. So for the 0db8, you can just omit that, and you get db8, okay? Additionally, if you've got 4 zeros, you can reduce that to a single 0. So you're basically saying, when you see this 1 0, you know it's assumed there are 3 other zeros in that hexdet because you have those 4 16-bit positions. Moving on down, you see different examples. I'm not going to spend a whole lot of time here, but this one's interesting because we got 0 1 0 0 0 0 1 0 0 0 0. Okay, so omit your leading zeros. The next one is one that trips people up sometimes, especially when you start getting questions in quizzes and on the exam. That is the double colon. We know that we have our hexstats. Okay, we have 8 hexstats. So we know that we can actually represent a series of zeros with a double colon, but we can't use more than one double colon, because then you don't know how many zeros are represented by that double colon. Right here, I don't know if that's 2 hexstats. You know, it's 1, 2, 3, 4. There's 4 here, so there's 4 missing, right? So we're looking up, we got 1, 2, 3, 4, 5, 6, 7, 8. We usually have 8 hexstats, but down here we got 1, 2, 3. We're seeing 4 of them, and we're saying that the double colon here represents some number of zeros, and this represents some number of 0 hexstats. Well, is this 2 and 2? Is it 1 and 3? We don't know. Okay, so this is a problem. What we can do though, let's imagine we have this format right here. So we got 2001 DB8 0000 quad 1s, quad 0s, quad 0, quad 0, 0200. We can take out this block and use the double colon to represent those 3 hexstats. So this very long preferred format becomes this compressed format IPv6 address. 2001 DB8 0 quad 1s colon colon 200. Now we know, because we've got 1, 2, 3, 4, 5, we've got 5 hexstats showing. We know that this represents 3 sets of zeros. The double colon does. It's 3 hexstats of all zeros. Say that 10 times quickly. Now here's where it really gets useful. Imagine this down here. We've got all quad zeros 1. This is the loopback address, by the way. There's the loopback address. So we can actually do colon colon 0, and that tells me that there are 7 all 0 hexstats in front of this 1 hexstat, or just colon colon, and that's all zeros. There's a mistake here in the curriculum, actually, if you'll notice. That is a mistake. FE80, all these quads, 0001, compressed should be FE80 colon colon 1, and it really should be FE80 colon colon 1 here, not FE80 colon colon 0. That makes no sense because we've lost a 1 in there. So be aware that's a mistake in the curriculum, and it has been put into the queue to be fixed, just so you know. So this is a neat little activity because it allows us to do quickly a colon colon 1. We can check it, woohoo, and then we can reset it. I say reset, reset, next, do another one. So now we know this is 2001 0 DB8. Oops, man, I messed that up. Some kind of fierce. DB. Huh? I don't know what's going on there. well, let me do it. D, there it goes, B8. 000 200. And then in compressed format, we could do 2001 1 colon 0 colon DB8 colon 1111 colon 200. That's correct. If you keep going, it just keeps giving you different ones that you can do. So you can go through every one of them so you can do all the ones in our issues. Okay. Any questions about preferred format, which is the long format, versus our compressed format? Any questions at all? Let me get my chat here. Okay. Peter, did you get audio back? Okay, good. Sorry. If you do lose audio, one thing I'll say is I'm recording this locally. So if you miss something and have a problem, when I post it up, just jump to that, try to kind of think of what time it was. We're about 26 minutes into the meeting, so you can kind of look around and see where that was, and you should have it. So, okay. And I'm sorry about that, but I've got slow internet out here in the middle of nowhere. I'm at again, I got cows for neighbors, and that's not saying anything bad about my neighbors. It's just they're literally cows across the creek. So let's look at our IPv6 address types. And one thing you will notice here, there are no broadcasts. That is correct. IPv6 does not use a broadcast address. You have unicast address, which is 1-to-1. You have multicast, which is 1 to some. And then you have this thing called Unicast that they don't talk much about at all. And it is 1 to the nearest of a device. And so we're not going to talk about them in this class, but basically think of it as, let's imagine that you wanted to, I don't even know if they really use it like this, but I'm going to use this as an example. Let's imagine you had streaming video servers throughout your network and you wanted to stream something. An Unicast address could be used to get the first one available or the nearest one to respond. And if I blew that on Unicast, that's my understanding of it. And you know, like I said, we don't even put Unicast addresses on anything, but we could do more work on that. That's part of the evolving nature of IPv6 as to what it will actually be used for. Okay. Now there is, we do not have a broadcast address, but there is an all nodes multicast address, which gives pretty much the same result. But it is not technically a broadcast. So in IPv6, we have in that 128-bit addressing space, the first 64 bits are called the prefix length, or the prefix. That is your network portion. The last 64 bits is your interface ID, and we're going to talk about different ways you can create or have an interface ID. You can set it, but you also can have it created. Well, you can't set it, but it can be randomly created, or it can be set based upon the EUI64 method, which is based upon your MAC address. But this is an example here of the prefix of 2001 DB8A :/64. That tells me it is this prefix right here. All right. We're going to talk about how prefixes are handed out in just a few minutes. So here again, we have different types of, we have unicast, multicast, and Unicast addresses. We'll talk about unicast and multicast in this class. In unicast, this is something very different than IPv4. An IPv6 host is going to have multiple IPv6 addresses associated with an interface. It's going to have, at a minimum, it's going to have what's called a link local address. And that's an address that allows it to communicate just on a single segment with the host on that segment. That link local address can be configured by you statically, or it can be actually created dynamically by the host itself. As soon as you enable IPv6 unicast routing on a router, that router will give itself a link local address using the method of dynamic allocation. You may or may not have a global unicast address on your interface. You don't have to. You would only need it if you wanted to be able to globally reach things. In other words, have a routable prefix. Loopback will be there, : 1/128. That is possible. And as we're going down here, you look, there is a thing called link local addresses, and there's a little bit, we talk about unique local addresses. Now, unique local is it's one of those evolving parts of IPv6. In fact, at one point, quite honestly, unique local addresses, the RFC said, let's get rid of these. We don't need these. Let's just do away with them. It didn't even depreciate it. So I'm kind of, I don't know why this is in here, but just so you know, a unique local address is the equivalent in IPv6 of an RFC 1918 address. So it is going to be, that's the use. But the problem is, we don't really have, or we do have NAT for IPv6, but we don't want to use NAT for IPv6 because one of the premises behind IPv6 is that we would have, again, complete traceability to a host. In other words, right now, you know how it is with NAT. If someone inside of your network is downloading movies, what happens to us at the school is we get a cease and desist order from the DMCA cease and desist order, and then you have to go and track down the inside host by looking at your NAT tables that actually downloaded that movie. And by the way, you can do it in Firewall too. Your Firewall usually keeps up with all this stuff. But there's not end-to-end traceability. I can't get to that one host. With IPv6, the way it is written is that every host will get an actual global routable IP address. Now, if that doesn't scare you, it should, because it scares me terribly for a couple of reasons. One, it scares me because security-wise, the implications that will open up. Second, the big issue that scares me is totalitarian regimes like China tracking down people like maybe a doctor trying to warn the world about a virus that's being spread, and then being able to track them to their individual host based upon a global unique prefix or global unique IP address. So there's some issues there that are going to have to be solved. And I don't know what's going to happen, but I will say from a security standpoint, we'll talk about something in a little bit that's going to be interesting when we talk about subnetting IPv6 and how hard it is actually going to be to scan an entire subnet of IPv6 addresses, because they're going to be huge. But unique local addresses are addresses that for IPv6 are equivalent to RFC 19 private addresses. Now, global unique addresses or global unicast addresses, GUIs, global unicast addresses, are globally unique and routable on an IPv6 network. At this point, only global unicast addresses with the first 3 bits of 001 or 2000 are being assigned. So that's basically only 1/8 of the total space of the IPv6 address space is available to the number authorities throughout the world to give out. The other thing they've done, which is very smart, is they're handing these out so that entire portions of the world can be summarized to 1 or 2 prefixes. So now, you know, the global routing table for IPv4 is over 300,000 routes. So if you're an ISP, you've got to have a router that can handle 3,000 routes in its routing table, which is, it's huge now with content addressable memory, not content addressable memory, but with express forwarding and other things. Now it's not quite as big, but still a big issue. Now we're going to summarize it so that our routing tables can be much smaller around the world and should be much more efficient. So you'll notice that we use all of our examples are 2001 DB8 : /32. That particular network or address has been reserved for documentation. That's why we use that in all of our examples throughout the curriculum. Now, this is really interesting here because the way that IPv6 is designed to be handed out is as shown right here. In other words, you're going to have a 48-bit global routing prefix. You're then going to have a subnet ID, which is 16 bits, and then a 64-bit interface ID. So let's do some, get my calculator here. let's go, we look. So, and by the way, this is how it's supposed to be handed out to you in your house. So in other words, you would get a /48 from your ISP. And that ISP, that means you will have 2 to the 16th subnets. So at your house, let me go up here. I need my scientific calculator. Oops. Scientific. So 2 to the 16th. So I got 65,536 subnets for my house. Okay. And every one of those has this many hosts on it. Okay, so I'm not going million, billions, I mean, that's crazy. All right, so you've got 65,536 subnets for your house of that many hosts. If your host picks a random address in the middle of one of those subnets, now just imagine, you want to do something security-wise, just have the host set up to where every 24 hours they pull a new address out of one of the subnets in the /48 prefix with some random interface ID inside of that subnet, and have that rotate every 24 hours. At this point in time, there's honestly no computer that could scan through this number of ports and this number of IP addresses and do an IP address scan, and it would be complete luck they would even find your IP address. Now, if they were monitoring your traffic in and out, obviously they could see it, but if they're trying to scan it, it's going to be extremely difficult. Now, once we get to quantum computers, all bets are off. Maybe you'll be able to do it in there's no doubt. In 10 years from now, you'll be able to scan that number of hosts in 2 seconds, probably 2 milliseconds. But this is the way it is supposed to be handed out. Now, are there any questions about this? Feel free to put them in chat. Any questions about how these are going to be handed out? Because that's the idea. Now, what may happen actually is that your local ISPs will take a /48 and then give you one of the subnets out of that /48. So you may be 2001 DB8 ACAD :::/64. So that may be something that you would be given. And again, that's just, I used the one that's for, so again, you may be given 2001 :DB8 :0:1 /64. So you'd be your first 4 octets, we get first hextets, 4 hextets are given to you. And then you would get IP addresses inside of there. Still, even if you get that, you've got so many possible interface IP or interface IDs that it'll be very difficult to scan that type of network. So again, it's going to be common for ISPs to give a /48 to their customers, and then there'll be 16 bits for the subnet. Okay. Now some of them some organizations may receive a /32 global. And then create 64-bit for the subnet ID, or excuse me, that's 32 and then 32. Just imagine that. If you get a /32 global routing prefix, you will get 4.3 billion subnets of 18 quintillion devices per subnet. This is, when an organization is given a /32 global, they have more subnets than there are public IPv4 addresses, which is insane. So we're talking about some huge, huge numbers here. And by the way, all zeros, all one host addresses can be assigned to a device in IPv4 because there are no broadcasts inside of IPv6. So now we talked about that's a global unique or unicast, global unicast address. If I call them unique, I apologize, but same thing. Global unicast address versus our link local addresses. Now, link local, again, are on a single subnet or a single segment, and they are always in the range of FE80::/10. So if you ever see an address, IPv6 address starting with FE80, it is a link local address. It is required. Global unicast addresses are not required, but link local are required. That's why machines will dynamically assign themselves one as soon as you turn on IPv6. And if you saw my example of my particular interface, you will see here that I do have a link local address, FE80, and then this is a random interface ID created by Windows. Windows used to use EUI64, but the privacy concerns that we'll talk about here in a minute made them switch to using dynamic interface IDs. So again, link local addresses, we'll talk about how they're used. They're actually used as the default gateway by your host. So your host can make their default gateway link local addresses instead of a global unicast address. Any questions on these two before we move forward? Do y'all know all this? Am I boring you senseless? If I am, I can go a little bit faster. I don't know if no news is good news, but I'm gonna go a little bit. I'll go ahead and let's see what we got here. It's all good, okay. Real quick, this is very simple. I'm not gonna spend much time on it. If you want to put a global unicast address on a router, use the IPv6 address command on the interface, just like you would the IP address command. You just put IPv6. By the way, 99% of your IPv6 commands you are the IPv4 command with IPv6 instead of IP. So we go in here and we just go to the interfaces and we put the IP addresses on them. Now I will tell you, you can put IP addresses on all day long, but until you put in the command IPv6 unicast routing, the router will not actually route between the different IPv6 networks. So be aware of that. If you ever get in a situation where you've got IP addresses, IPv6 addresses on the router, but it's not routing even between its individual interfaces that are configured, make sure IPv6 unicast routing is turned on. Host, you can put in a static address, or we'll talk here shortly about how they can get their own addresses. By the way, you sometimes and many times, especially in packet tracer, you set the default gateway to the link local address of the router. You can also do that with your host. All right, so let's talk a little bit about, we got a whole section on static dynamic configuration of addresses, and we'll talk about that in just a second. So I'm gonna skip over this right now until we get there. But so let's imagine you want to do a static configuration of a link local address on a router. Now the example they're showing here is they are showing FE80::1 being assigned to G00, S010, and then gig 010. Each one of them they're showing. The only thing to make it a link local, you just put link local after. Now, I'll be honest with you. You can just put FE80::1, and you can use that for every single link on R1. So in other words, all of R1's link local addresses could be configured on every single one because it's only going to be used on the link it's connected to. So in this instance, FE80::1, I wouldn't put this additional :1. I don't know really why they've done that. Just I guess that's because it's router 1. But FE80::1, you could put and make it on gig 00. You could put the same thing on S010 and the same thing on gig 001. The thing is, in fact, that's what I would do. Then on router 2, you can put FE80::2 link local on every single one of its interfaces. That way you know that router 1 has got 01 or 1, and then 2 on 2, 3, 4, so on and so forth. Setting the link local addresses is so much better because then you don't have this long link local address that you had to try to type in. All right, now let's talk a little bit about dynamic addressing for global unicast addresses. There are 3 different methods for this. There's SLAC, stateless auto configuration. there is, let me scroll down here, there's Slack, all right, which is, I send out a router solicitation, the host does, I don't, but the host that wants an IP address, IPv6 address, sends out a router solicitation. The router responds with a router advertisement, and if the host is configured for Slack, the router will say, I have everything you need, here's your prefix, in other words, your major network prefix, the length of that prefix, and here's the default gateway address. Now you will notice the problem with that method is we're not getting DNS servers, we're not getting any other of our normal options, our scope options that we get from a DHCP server. But for basic connectivity, Slack works perfectly. So it'll hand you just these two right here, your network prefix and length and your default gateway address. There's another way the router can respond. The router, when you send out a router solicitation, you can have, and let's just go down first with Slack. Let me show you Slack. So the router advertisement goes out, and by the way, routers advertise themselves every 200, I believe it's every 200 seconds. That's what it is. It's in the curriculum right here somewhere, but every 200 seconds, they advertise themselves regardless of whether or not they get a router solicitation. But let's say this host boots up. When it boots up, if it's configured for DHCP, in other words, as we look at our previous slide, I'm not going to go back now, but if you'd set your host to be dynamically assigned an IPv6 address, as soon as the host is connected and the interface comes up, it's going to send out a router solicitation. The router will send its advertisement and give it its prefix and its prefix, the prefix length, and then the host is going to create itself either a random ID or an EUI64 based ID. This one is EUI64 more than likely because in the center it says FFFE. That is the clue, or that is the key to tell you that it's an EUI64 address, and we'll talk about that in a minute. Now, technically, that could be a random generation, but most times you see FFFE, you're going to know that's EUI64. It'd be a very unlikely coincidence that you would randomly generate one with FFFE in the middle. So that is Slack only. There's another thing that can happen. The host can send out a router solicitation message. The router can respond with, okay, here's your prefix length, and here's your default gateway information. But also, if you need to get some DNS information, here's the DHCP version 6. You need to ask your DHCP version 6 server. And then at that point, the host will send out a DHCP v6 solicit, and then a stateless DHCP v6 server will respond with its DNS information. So it's other basic information. So the PC basically says, I got my IP address, my IPv6 address, but give me other information I need. Give me my DNS information and anything else that you're configured to give me. All right. So that's another way. Very different from IPv4 DHCP. Now, this, however, stateful DHCP v6 is extremely similar to IPv4. So the client sends out a router solicitation message, which by the way is multicast to the all routers multicast address we'll talk about here shortly. And then it gets back a message that says, look, I'm sorry, I appreciate you wanting an IP address from me, but I can't help you. I am your default gateway, but you got to ask a DHCP v6 server for all your other address and information. At this point, a DHCP solicit goes out, and the stateful DHCP server responds with, okay, here's your IP address, IPv6 address, here's your prefix length, and all the options that you will need. So you'll notice that even in the stateful DHCP method, the first questioning goes to the router, not to the DHCP server. So it's very different than what we've seen before. And by the way, you can make these bigger if you didn't know that. You can always make these bigger when you're presenting in class so that your students can see it if you need to. But that's different, very different. Okay. Questions about stateless auto configuration with stateless DHCP v6, and stateful DHCP. Any questions on those three? You'll see those somewhere. I'll put it that way. Control Alt, what was that? I want to see if I can do that. Control Alt Shift H. Control Alt Shift H. Huh. Oh, that's cool. Didn't know you could do that. Really cool. Oh, that's neat. Learn something every day, folks. I know people are worried about Zoom and worried about it being hijacked, and I'm not that worried with this class. Nobody's that interested in us. So now, once you get this information, you can randomly generate your interface ID, or you can use what's called the EUI64 or Extended Unique Identifier, or modified EUI64 process. And here's the major problem with the EUI64 process and why people have quit using it. It takes your MAC address. Well, folks, that is very much globally unique. That's, by the way, how they caught the bind, torture, kill, the BTK killer. They caught that person because that person sent a Word document to a newspaper, and inside of that Word document was the, in the metadata was the MAC address of the PC that had created the document, and that allowed them to basically arrest a person they had thought was possibly a killer for years, but had no evidence of. So, you know, if you know somebody's MAC address, you can track down their machine pretty easily. So that's why this method is not as popular as it used to be. It's confusing. I will go ahead and tell you only for one reason, and that is to make an EUI64, you need 64 bits, obviously. You got 48 bits, so you're going to put in the additional bits. So you break the EUI or the MAC address into two parts. The WE, or the Organizational Unique Identifier, and you know this is what identifies who made the NIC. And then the device identifier was 24 bits. To make an EUI64, you divide it in the middle. You flip the 7th bit. So you'll count left to right, and you flip the 7th bit. I have no clue why, folks. I have tried. I don't know. I've tried to understand the universally and locally bit and reversing it. I no clue. Okay, if somebody else knows, please let me know, because the only thing I can figure is maybe that just helps, that randomness helps to make sure that when you generate it, they're not going to be the same. Okay, but you flip that bit. If it's a 0, you make it a 1. If it's a 1, you make it a 0. Then you stick in FFFE in the middle, and that gives you this new device identifier for IPv6. So a 64-bit address. So again, divide the MAC, flip the 7th bit, stick FFFE in the middle. And, you know, that's just, if you see this, that's the reason you want to know. If you see FFFE, that is 99.99% likely to be an EUI64 address. So if you want to find somebody, just take this part right here, write out in binary, flip that 7th bit, and then go find out, you know, what machine it is and who created it. This is better. Generate it randomly so that people can't track you. So dynamic link local addresses, that's something that can happen too. By the way, that's what hosts do. They dynamically create themselves a link local address, just like mine. This is a dynamic address here, FE80::, and then the host ID, which is that portion right there. Okay. So hosts will create their own, and your routers will do the same if you don't statically assign your link local addresses on IPv6. So here you see an example. This is using EUI64. This is random. And by the way, Windows just puts this %11 here. That's just the output and the way they do it in the programming. So not completely sure why. But it is just the way Windows outputs it. That's not part of the address. The address is right here. Okay. So you can do that on the router. Same thing. By the way, I would statically assign all of my link local addresses, just because, think about it, if you try to put that, ping that on a local, from the local segment, that's a whole lot to type versus FE80::1. So it's just really for simplicity's sake. Configuration commands, it's exactly the same, folks. Just use IPv6, show IPv brief, IPv6 brief, show IPv6 route, and ping just uses the same thing, but with big old addresses. We'll real quickly go through these multicast address. I just want you to know that there are two types of multicast address: well-known multicast address and solicited node multicast address. We'll start with well-known first. The first one is the all nodes multicast group, which is FF02. By the way, all IPv6 multicast start with FF02. I would know that. It could show up somewhere. So it's FF02::1. All devices join that. So technically, this is the broadcast address because it's the all nodes multicast group. Send something to FF02::1, and everything on that segment will see it. FF02::2 is the router, is a multicast group that all routers join when you put in the IPv6 Unicast routing. This is also what is used for the router solicitations. Okay, so when you do a router solicitation, you send it to FF02::2. The router advertisement sends router advertisement message to FF02::1. So that's how solicitation, and then this is router solicitation, router advertisement. Actually, this is a router advertisement here from the router. This is very, very confusing unless you do a little research on it, folks. Solicited node IPv6 multicast address are a multicast address that is created based upon using the MAC address of the machine. And it is used for ARP functionality in IPv6. In other words, ARP, remember, if you will, ARP in IPv4 requires you to send a broadcast, an ARP request, to get an ARP reply. We don't have any broadcast technically in IPv6. So if I have an IPv6 address and I need to know the MAC address, I can do a solicited node multicast, and I generate that from the IPv6 address, and then the host will respond because it is related to their NIC. Do a little reading on it. It's not going to be a whole lot in what we have to do in terms of knowing IPv6, but be aware it's to allow for ARP type functionality inside of IPv6. All right. So finally is probably the easiest thing there is about IPv6, and that is subnetting. Subnetting is ridiculously easy in IPv6 because you have 16 bits set aside for subnetting, which means you have, again, 65,536 subnets of up to 18 quintillion hosts. 18 and all the zeros here, and I showed you that earlier. Here's how easy it is. First subnet is 0. Second subnet is 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E. If you get an example, by the way, if somewhere on the test possibly that you're asked to use subnet IPv6 subnet A and IPv6 subnet B, that literally would be that is subnet A. That is subnet B, and that's technically subnet 10 and subnet 11. So as you look here, you're looking at 9, 10, 11, 12, 13, all the way down. And so then it would move over to 0001, 0001, 0, 0001, 1, 0012, 013. So it goes all the way down. So subnetting in IPv6 is very easy. You're not borrowing from the host portion. You're using just the 16 bits set aside in the first 64-bit prefix. So you got 48 bits for the global routing prefix and then 16 for that subnet. So it's very easy. All right, so go ahead. Okay, good point. Corey says the 7th bit on our example before about EUIs, indicates whether or not it is an actual MAC universal or locally generated MAC, from my understanding. Okay, well, that would make sense. So, but we're flipping it. The only problem, that I understand what you're saying, Corey. The only thing that bothers me about that is, the only thing that bothers me about that is if we're flipping that bit, okay, so it's one, oh, I know, of course I understand it fully, but, and if that stands for that's locally generated or universal, and we flip it, it seems like it would be the same on every single MAC address if it was burned in and would be flipping it. And that may be true. That may be true. I don't know. I got to do more research on that. Like I said, EUI is kind of, that's one of those things, talk about evolving. That's one of those things that's kind of going away, simply because everybody's using randomly generated now instead of UI. But hey, subnetting is stupid simple. You just use 0 through FFFF, and that's your subnets. So, and you got 65,000 of them to play with. So I, for one, will be very happy when we go to all IPv6 because it's so much easier than IPv4. And folks, that's it. That's our entire module on IPv6. Are there any questions from anyone? You got to know how to configure IPv6 on a router. You got to know how to put an IPv6 address on. So make sure you're doing those labs in here. Make sure you've got, and that's the lab. This is on NetLabs. You're actually going to configure it. So the other thing is, remember, always use the documents from inside of NetLabs. Do not use this document. Make sure that when you log into NetLabs, you log into NetLabs and you go to do a lab. And I know you all know this. By the way, I do apologize too if you've been trying to use the labs and they're in huge use. I'm trying to help as many people as I can with allowing them to use our labs. But right here, configuring these addresses, if you look at the preview, you'll see that it is updated for NetLabs Plus. So this document could be different than the document in the curriculum. So always use the one that is inside of NetLabs. Any questions? Any issues with class? Okay, I'm going to actually go ahead and I'm going to stop sharing my video. Stop sharing. I'm going to stop.